Hello, grade 10. How are you? This is our 10th online lecture, and in this lecture, I'm going to continue our lesson that we have started last week. It's about powers and radicals. So last week, I just did a revision for something you have learned last year, but in this video, I'm going to continue to explain something new. So what I'm going to explain this week is we are going to define the nth root and we are going to rationalize the denominator of a fractional expression. So let us start defining the nth root. The nth root, as you can see in this expression, it's the nth root of a. It's not the square root. So you used to find the square root of a number. In this lesson, we are going to find the nth root of a number. So n is the index number. It could be 2, 1, 3, 4. This is the radical, of course, and this is the radicand, which is a. This could be expressed as a to the power of 1 over 2. So, whenever you have n greater than 1, of course, you will have the index number becomes the denominator of the exponent. So, a, it's actually to the power of 1. So, 1 over the index number. So, the index number here became the denominator of the exponent. So n radical a or nth root of a, if n is odd, then we have only one real root. If n is even, we will discuss some cases. If a is positive, then we are going to get two real roots. If a is 0, then we are going to have only one real root, which is 0. But if a is negative, then we are not going to have any real root. Let us make this as a table and take as an example. So as I told you, if n is an even root, then we will have two roots, one positive and one negative. So if we have radical 64, then we are going to have plus or minus 8. But if we have even root, so suppose here we have 2. If we don't have any number, then it's 2. That's why we call it square root, because we have 2. So if it's negative inside and we have here an even root, then this is undefined. We are not going to have any root. Now, if we have an odd root, so if here we have the index is odd, then we are going to have only one root and it's positive. It's 64. How did I know that it's 4? How did I know that it's 4? You know that 64, it's 4 to the power of 3. It's 4 to the power of 3. So if you put 3 over 3, you're going to have 1. So it's 4 to the power of 1. If we have a negative number inside and this is the index is odd, then we are going to have also one negative root, which is minus 4. So pay attention. If we have even roots, then we are going to have plus or minus the number, the solution. But if we have even root and a minus inside, this is undefined. If we have odd root and positive inside, one positive root, and if we have odd root and negative number inside, we have also one negative root. Now, how do I change from radical form to exponential form? So suppose you have 3 radical x squared. 3 is the index, and inside we have x squared. As I told you before, the index becomes the denominator. So this will give me x to the power 2 over 3. So I change from radical to exponential form, only exponents without radicals. So any radical now you can change it into a fraction like this. Or I can write this x to the power 2 of 3, I can write it 1 over x to the power 1 over 3 squared. How can I do this? You know that if I have those, I can multiply them. So already I have 2 over 3. I can split it into 1 over 3 squared, or even I can put the square inside and 1 over 3 outside. Of course, as needed. As I need in the question, you can do it. But the main thing that you have to know is to change from the radical into exponential form. Now, from exponential to radical, if I want to do the opposite, so suppose you have x to the power 2 over 3. As I told you, the index becomes the denominator. So this is the index. So this is cubic root. We say that this is cubic root of x squared. Or as you can see, you can do it like this. Cubic root of x to the power of 2. The denominator, as I told you, of the exponent becomes the index of the radical. Now let us evaluate without a calculator. As you can see here, we have cubic root of minus 8 to the power of 5. This could be changed into, you know that 8 is 2 to the power of 3. So keep in mind, this is an odd root. With a minus inside, I have only one root, which is negative. So it's minus 2 to the power of 5, which gives me minus 32. So you have to pay attention very well, because if the index was an even root, then this is impossible to find. But because it's an odd root, it gives me one negative root, which is minus 2, and to the power of 5, which is minus 32. The second one here, we have we have 4 as an index of radical 32. You know that 32 is 2 to the power of 5, so this could be changed into 2 times 2 to the power 4. I just split it, the 2 to the power 5, into 2 to the power 4 times 2. Why? Because here I have an index of 4, so this will be outside as 2 radical 2, but we have an index 4. You still remember when we had radical 2 squared, we used to tell you that you can get rid of the square with 2. Why? Because as I told you before, if I don't have here any number, then this is 2. So 2 over 2 is 1, so 2 to the power 1. So this was one case of the roots that I have. The same thing here, if I have 4 radical 2 to the power of 4. In this case, 4 over 4 is 1, so the answer is 2. So 2, 4 root of 2. Okay? Now solving an equation. So suppose you have x to the power of 4 minus 7 equals 9,993. So this will give me x to the power 4 equals 10,000. So how can I solve this? If I have, when we used to have, for example, x squared equals 9, we used, sorry, this is 9, x squared equal 9. We used to tell you that you can put here radical. Why can I put radical? Because actually this is the square root. So in this case, it will give me x 3 plus or minus 3. Right? The same thing here I'm going to do. I'm going to put the 4 root like this. I'm going to put the 4 root like this. So it will give me x equals plus or minus 10. As I told you before, if we have an even root and a positive number inside, I'm going to get 2 roots, one positive and one negative. And how did we know that it's 10? You know that 10,000 is written as 10 to the power of 4, and in this case 4 over 4 equals 1, so it's 10 to the power of 1. Of course, we don't put it, we put it like plus or minus 10. And in this case, 4 over 4 is 1. They cancel each other, and we will get x. Let us continue. So the index number is even, therefore two answers, as I told you before, or 2 solutions. Now let us take some rules. If we have radical nth root of a times b, it's the nth root of a times nth root of b. We can split the root among the two. And also, if we have them as quotient, we can split the nth root among them. So nth root of a over nth root of b. So you can split the root. Let us take this example using the quotient property. So we have fourth root of 16 over 81. So 16 is written as 2 to the power 4 and 81 is 3 to the power 4. So in this case, 2 to the power 4 over 4 is 2. 3 to the power 4 over 4 is 3. And adding and subtracting radicals. So what if I have the root of a number and we need to add and subtract radicals? You have to keep in mind that two radicals are like radicals if they have the same index number and radicand. So for example, if we have the cubic root of 2 and 4 cubic root of 2, they are like radicals. Why? Because here I have the same radical with the same radicand and the same index number. So those two, I can add them and I can subtract them because they have the same index and the same radicand. So for addition and subtraction is done only with like radicals. Let us take an example. So suppose we have minus 4 root of x plus 2 4 root of x. This is equal to 4 root of x because minus 1 plus 2 I can add them. Minus 1 plus 2 is plus 1. So this is the answer. And same index number and same radicand, we only add the coefficient. The same thing is going to happen in subtraction. So whenever you have like radicals, you can subtract them. So look at this. We have here we can say that we have still the same radical because I need to simplify the first one. So the first one we can change it into 2x radical x cubed minus x radical x cubed. So now I got the same radical with the same index, so I can subtract them. 2x minus x is x radical x to the power of 3. Now rational exponents. So the definition of a to the power m over n, as I told you, it's n radical a to the power of m. So the denominator will always become the index. So let us take some examples. If we have 25 to the power of half is written as radical 25, which is 5. 27 to the power 1 over 3, it's 1 over 3, it's the cubic root of 27, and 27 is 3 to the power of 3, so it's 3 because 3 will goes out with the root, so it will stay 3. Now 4 to the power of 3 over 2, it's the square root of 4 to the power of 3, which is 4, it's radical 64, which is 8. Okay, so you can do it because 64, it's 8 squared, so the answer is 8. Now if we have 2x plus 1 to the power 2 over 7, so it's the 7th root of radical 2x plus 1 squared. Of course, this I can solve it because we can simplify inside. And if we have 1 over 27 to the power 2 over 3, I'm going to put it to split the exponents for both the numerator and the denominator, then write them as radicals, and then you can simplify. 729, it's 9 cubed, which is 9. So of course the cubic root of 1, it's 1. And you can do like this, you can change it for, yes, like this, 1 squared over 3 squared. So both of them will lead me anyway to the same answer. Now if I have a negative, we already learned this before last week, that if I have a negative exponent, I can take it to the denominator and then I continue normally as we learned, like this. So as an example, if we have 25 to the power minus half, we take it to the denominator, so it's 1 over 25 to the power of half, which is 1 over radical 5, 1 over 5, that's it. The same thing in the second one, we are going to take it to the denominator, then we write it as a radical. Now, We are going to use the properties of exponent to simplify an expression. So if I'm multiplying two variables, you know that we can add the exponents because I have the same base. So it becomes x to the power 9 over 3. Then I write it like, if here we have a step which is x. If I want to write it as a radical, this is outside I have 3 and inside I have 9. So 9 over 3, it's 3. So it will lead me to the same answer. Okay? The same thing in fraction, I can subtract the exponents. So I got x to the power 5 over 10, which is x to the power half, which is radical x. You can write it as radical, and you can keep it as x to the power half. It depends on the question if I ask you to express it as a power or as radical. Now we have here, you should simplify inside. So it's, you know that 81 is 3 to the power of 4. So 3 to the power of 4 will goes out 3 because here I have 4 as an index. X to the power 2, you put 2 over 4, which is like this is 3x to the power of half. Of course, if I ask you to write it as a radical, this is 3 radical x, because x to the power half is radical x. The same thing in the last one. As you can see, I'm multiplying two radicals with different indexes. So what you are going to do is to change every one into a fraction, and now you can add the exponent. So you are going to get x to the power 9 over 12, which is x to the power 3 over 4. And product rule for square roots. So if radical A and radical B are multiplying them, you can split the radical. You know this. I'm just going to remind you of this. We already learned it last week. So we can split the radical. We can put the final answer. Those are very easy. But what I'm trying to reach is, if we have the cubic root of 16 x to the power 17, you can split the root like this, 8 times 2x to the power 15x squared. So this will give me, you can split each one alone. So 8, it's 2 cubed, so it goes out 2. X to the power 15 over 3, it's x to the power of 5. 2, I can do nothing with it. And x to the power of 2, it stays inside because here I have cubic root. So they are similar with the square root, but the difference is that I should get a power of 3 inside, like for example 2 over 3, or a multiple of 3 to go out, else it's going to stay inside the radical. Examples: 3 cubic root of 88. It's a cubic root of 8 times 11, and 8 is 2 cubed. So 2 will goes out, and I will still get a cubic root of 11. Now here also I can split the cubic root among both of them. The numerator will have no change because 10 is 2 times 5, but 27 is 3 cubed, so it will goes out as 3. Also here I can split the cubic root among all of them. So 27, it's actually 3 cubed, so it goes out 3. M cubed will goes out m, but n, I will split it into n to the power 6 times n, which gives me the final answer. As you can see, it's radical n will stay inside because this will stay inside, as you can see. Okay, so here also I can split it like this, 81. So it's 3 cubic root of 3 over 2. Practice them. You should practice them alone. And now we go for the final example, which is fifth root of 64 x to the power 12, y to the power 4, z to the power 18. So each one alone, so 64 is 32 times 2. And x to the power 12, I'm just splitting them into multiples of 5 with the remaining, and y to the power 4 will stay as it is. Z to the power 18, it's z to the power 15 times z to the power 3. I'm doing this just to see what can I get outside. So here 32, it's 2 to the power 5, so it goes out 2. X to the power 10 will goes out x to the power 2. Z to the power 15 will goes out z to the power 3, and the remaining inside is 2x squared y to the power 4 z to the power of 3. The last thing I'm going to explain is rationalizing the denominator. So if I have 1 over radical a, I multiply by radical a over radical a, so it gives me radical a over a. You know this from last year, but the new thing that you are going to take is that how can I rationalize the denominator if I have nth root of a to the power m? It's very easy. Then you have to multiply by the numerator and the denominator by nth root of a to the power n minus m. You have to study this. Okay, so let us take an example to understand this. So if I have I'm going to start by part B. If I have 1 over cubic root of 5, I should multiply by, as I told you, m minus n. So here I have at 3 minus 1, because here I have power 1. 3 minus 1, it's 2. So I need to multiply here by 5 squared. Why? Because actually 5 times 5 squared, it's 5 cubed. So you are going to add them to get 3, to get rid of the 3. So it goes out like 5. Here I have 1 over fifth cube of x squared. So you have to multiply by 5 minus 2, it's 3. So fifth cube of 3. Okay, so always subtract the index from the exponent inside, because whenever you add x squared and x3, you are going to get x5, and 5 goes out with the 5 to get x. That was everything for this week. Of course, if you have any question, you can keep them for the live session, for the coming live session.